Winter is coming. The motto of House Stark. It has never felt more true for our planet Earth. You may think that seasons and climates are constant, but the truth is there are cycles at play that affect the Earth's climate and seasons. The Milankovitch cycles, from ice ages to milder summers, have shaped the Earth for thousands of years. Join us as we uncover the secrets of these cycles and discover what the future holds for our planet. Is winter really here? Have you ever wondered why we have seasons such as winter, spring, summer, and fall? Everything is due to the tilt of Earth's axis. Because the Earth is tilted at an angle of about 23.5 degrees, different parts of the planet receive varying amounts of sunlight throughout the year. Because of this tilt, the seasons change as Earth's orbit moves closer or farther away from the sun. However, it is not only the tilt that causes the seasons to change. The tilt of the Earth also has different effects on the northern and southern hemispheres. For instance, when it is summer in the northern hemisphere, it is winter in the southern hemisphere. The northern hemisphere is tilted towards the sun during the summer solstice, resulting in longer days and warmer temperatures. In contrast, the northern hemisphere is tilted away from the sun during the winter solstice, resulting in shorter days and colder temperatures. Similarly, the seasons in the southern hemisphere are reversed, with the summer solstice bringing longer days and warmer temperatures, and the winter solstice bringing shorter days and colder temperatures. Interestingly, the tilt of the Earth changes over time in a 26,000-year cycle. This means that the axis of Earth wobbles, much like a spinning top slowing down. This wobble is known as the precession of equinoxes. It alters the direction of Earth's axis tilt. This causes the tilt to shift over time, affecting the severity of the seasons. But as of now, the Earth's tilt is currently in a declining phase. And according to many researchers, this tilt decline may result in an ice age in the future. The reason is that the decline in tilt can cause the snowball effect. The snowball effect is a process in which the Earth's climate gets colder and colder, causing ice sheets and glaciers to grow. This occurs because the tilt decreases. So does the amount of sunlight that reaches the Earth's surface. As a result, less sunlight is absorbed and more is returned to space. By reflecting more sunlight back into space, the snowball effect can cause an ice age. This reflected sunlight cools the Earth's surface, resulting in the formation of ice sheets and glaciers. The Earth's tilt also affects the planet's climate and can lead to extreme seasons, which will bring colder winters and milder summers. All of this is explained by Milankovitch cycles, named after the Serbian astronomer Milutin Milankovitch. These cycles include changes in the Earth's orbit, tilt, and precession, which affect the amount of solar radiation that reaches the Earth's surface and can lead to climate change. One of the most significant effects of the Milankovitch cycles is their relationship with ice ages. These cycles correspond to the timing of ice ages, with eccentricity, tilt, and precession all playing a role in the onset and duration of these cooling periods. The Earth's orbit around the Sun changes in three ways. First, the shape of the orbit changes from being almost circular to being more elongated or elliptical. This change in the shape of the orbit is known as eccentricity. Second, the tilt of Earth's axis changes, which affects the distribution of sunlight received by Earth. This change in tilt is known as obliquity. Finally, the Earth's rotation axis wobbles, a phenomenon known as precession. These changes in the Earth's orbit and tilt affect the amount of solar radiation that reaches the Earth's surface. When the Earth is closer to the Sun, more solar radiation reaches that surface, and when the Earth is farther away, less radiation. The tilt of Earth's axis also affects the amount of solar radiation that reaches the surface. Naturally, when the tilt is greater, the poles receive more sunlight, which can lead to warmer temperatures. When the tilt is less, however, the poles receive less sunlight, which leads to colder temperatures. The combination of these three things changing in the Earth's orbit and tilt can lead to the onset of an ice age. When the eccentricity of Earth's orbit is at its highest, the Earth is closest to the Sun during the northern hemisphere's summer, which can lead to warmer temperatures in the northern hemisphere. When the tilt of the Earth's axis is at its highest, the poles receive more sunlight, which can also lead to warmer temperature. However, when the precession of the Earth's axis is such that the northern hemisphere's summer is during the time when the Earth is farthest from the sun and the tilt is at its lowest, the northern hemisphere can experience cooling and the onset of an ice age. To better understand the upcoming ice age and Milankovitch cycles, we also need to understand the concept of interglacial periods. Imagine Earth as a giant freezer, where ice ages are the deep freeze and interglacial periods are defrosting. Right now, we are in one of these defrosting periods, and it's keeping us from experiencing a full-blown ice age. But what's keeping us from entering a full-blown ice age right now? The answer is the current interglacial period. An interglacial period is a time when the Earth's climate is relatively warmer and ice sheets retreat, allowing for the growth of vegetation and the proliferation of life. We're currently in an interglacial period, known as the Holocene, which began around 11,700 years ago. This warm period has allowed human civilization to flourish. You might be wondering, so why are we currently in an interglacial period and not an ice age? As we explained earlier, the Earth's tilt and the Milankovitch cycles play a big role in determining the planet's climate. But the key factor that's keeping us from experiencing an ice age right now is the amount of solar radiation that reaches the Earth. During an ice age, less solar radiation reaches the Earth due to factors such as changes in the Earth's orbit, leading to a cooling of the planet's surface. But during an interglacial period like the Holocene, more solar radiation reaches the Earth, leading to the warming of the planet's surface. But according to researchers, the interglacial periods like the Holocene do not last forever. The Earth's climate is constantly changing and the Holocene will eventually come to an end. Scientists estimate that the current interglacial period will last for another 15,000 to 20,000 years before the Earth enters another ice age. The Holocene is just a blip in the grand scheme of Earth's climate history, but it's not just the Milankovitch cycles that impact the Earth's climate. Sure, they play a big role in the timing of ice ages, but there are other factors at play as well. One of the most well-known factors is the level of greenhouse gases in the atmosphere. Greenhouse gases, such as carbon dioxide and methane, trap heat from the sun and warm the Earth's surface. This is known as the greenhouse effect. When there are higher levels of these gases in the atmosphere, the Earth gets warmer. And when levels are lower, the Earth gets cooler. Think of it like a giant blanket wrapped around Earth. The thicker the blanket, the warmer the Earth will be. And the thinner the blanket, the cooler it will be. Greenhouse gases act like the thickness of the blanket, trapping more or less heat depending on the levels. Humans have played a big role in increasing the level of greenhouse gases in the atmosphere. We burn fossil fuels like coal, oil, and natural gas, which releases CO2 into the atmosphere. We also chop down forests, which remove trees that absorb CO2. And we use land for agriculture and urban development, which releases methane from the soil. So while the Milankovitch cycles are important, they're not the only ones affecting the Earth's climate. Greenhouse gases play a big role too. It's like a giant game of climate Tetris, where different factors are falling into place, and we are trying to figure out how to make the perfect fit. The motto of House Stark, "Winter is coming," serves as a reminder that it's crucial for us to learn more about these cycles, to take action and protect our planet. We hope you enjoyed this video. Make sure to subscribe, like this video, and hey, watch these ones as well.